Hello, everyone. Welcome to the NRMCA's webinar, Designing Concrete Parking Lots and Streets. My name is Phil Kresge. I'm Senior Vice President of Local Paving for the National Ready Mix Concrete Association. And with me today is Amanda Holt, who is the Senior Director of Local Paving. And Amanda will be giving the brunt of the presentation. I do have some housekeeping that I want to go through first before we get started. And the first is regarding the presentation itself. Everyone muted. We've got quite a few folks. We're well over 400 people, and I think that's fantastic, and I appreciate the interest in the topic. But we're going to keep everyone muted, and if you have questions, please type the questions into the question box. We're going to, at the end of the session, we'll take a look at the questions and try to answer all of them. We'll make sure that no questions are left unanswered. We are also recording the webinar, and afterwards you will be able to upload or download a copy of the webinar on our NRMCA YouTube channel. It'll take a couple of days to get that up, but it'll be uploaded. And also, there are a couple of handouts right now that you can access if you look on your toolbar. There are two handouts there. One is a out of the presentation, so you have the slides there, and the other is contact information on the Pave Ahead team. As far as the course credit is concerned, it does have continuing education credits. It's based on your attendance. And after the webinar is completed, you'll get an email, follow-up email with a survey, some questions there. We would ask you to please fill those out. It's not required, but we certainly encourage you to fill those out. We use that information to improve our webinars rather. As far as the certificate goes, about an hour after the webinar, you'll get a follow-up email, and in that email, you'll be able to get your certificate for your continuing education, for your PDH. If you are an AIA member and you provided us your AIA number, we will register that with the American Institute of Architects. The presentation, as all presentations from NRMCA, we strive to be as accurate as we can, but we disclaim any responsibility for your application of the information. And also, because there are so many folks here, I need to let you know that we're going to abide by the NRMCA's antitrust policy. We're going to refrain from discussing costs, actual costs, and so on. If you're looking for estimates on what the costs of concrete pavement might be, my recommendation would be to reach out to your local ready mix producer or concrete paving contractor, and they can give you some examples there. I want to take the time to thank our sponsors, BASF Master Builders, Euclid Chemical, GCP Applied Technologies, and Sika. Without their continued support, we at NRMCA wouldn't be able to provide a lot of the resources we do, and we thank them for that. Our agenda for today, we're going to finish up here in a little bit with some introductions of NRMCA and our speaker, and then Amanda is going to come in and talk about why we are here, the reason for this type of presentation. She'll talk about the design elements of a concrete parking lot and concrete streets, the different design tools, and then I'll come in at the end and review some of the resources that are available from the NRMCA. For those who aren't familiar with NRMCA, we are a national trade association. We've been around, this is our 90th year. We are currently housed in Alexandria, Virginia, after many years of being in Silver Spring, Maryland. But we're right there in the Beltway, and we're there for a reason, because we represent the concrete industry, not only in engineering and promotion, but also in government affairs. And we're there to be the voice of the industry in Washington. We currently have about 1,100 member companies, and they represent 75 to 80% of the North American production of ready-mix concrete. Our mission is to serve the industry and our partners, and we do that through our 5 divisions: compliance and operations, where we assist you being better at business; with engineering, where we represent the concrete industry at ACI, ASTM, and other organizations; our government represents and defends, if you will, the industry on Capitol Hill and supporting on a local level. And then our two promotion divisions, structures and sustainability, which is pretty much self-explanatory, and then local paving, which covers parking lots, streets, roads. We don't get into mainline paving as much. We have other associations, American Concrete Pavement Association, for example, that we partner with there, but we lead the charge on the local paving. And our local paving team consists of professionals around the country. We are, I'm not, I guess I sound egotistical here, but we feel like our team has some of the best that the industry has to offer. We've got years here, and we're here to support and help our members and our contractors and our customers all that we can. A little bit about our speaker today. Amanda Halt is a graduate of the University of Florida. Prior to coming to the NRMCA, she spent 9 years in land development and 3 years in market development and parking lot promotions for one of the larger cement manufacturers. Since joining NRMCA and being the Senior Director of Local Paving, she focuses on the streets and roads and parking lots promotion. She's quite well versed in new construction and overlays and rehabilitation. And as far as industry support goes, Amanda is our lead on the Design Assistance Program, which you're going to hear about a little bit later. And so with that, I will introduce to you Amanda Halt.
All right, thanks, Phil. I appreciate that. So everybody is here today for a purpose, and we're gonna really dive into looking at concrete parking lots as well as streets. So the purpose of this web to sit through today, and we go over some of the design basics of both parking lots and concrete streets. We hope that you can then be able to take the information that's provided and then use the appropriate pavement design methods for both of these types of pavement applications, as well as the identifying which inputs are necessary to do a well-designed concrete segment. So education is for concrete pavements is very, very important, and in many aspects we actually lack in the college or the university's exposure to these different types of education opportunities. And because of that, we end up seeing that we have concrete sections that are not equivalent to those of asphalt. Primarily, that is what we are up against in the market of pavements. And so we get a concrete versus an asphalt parking, or either a parking or a streets and local roads section, and they're not structurally equivalent, but we want the initial cost to be rather competitive, and we can't make that happen in most cases. And so we really need to look at the structural components of both of those and get a really more of an apples to apples comparison. I want to start off by addressing the slide regarding who designs pavements. This is a slide that I really like to talk about and really kind of dig down into it. And depending on where you are in the design layout of a project is going to have a very different aspect of how you see these different roles played out. From, again, my background, I did land development in the Jacksonville, Florida area for years before I came into the industry. And so my relationship with an architect, they were typically the one that had the ear of the owner. And so they really didn't get into design too much. Now, in my travels across the U.S. with NRMCA, I have found architects that do the pavement design. And so it's important that those architects are exposed to the different elements that go in to the design so that they know what they're looking for and how to properly design it. But for the most part, from the architect at the loads or the vehicles, what we're going to be designing our parking lot for. The geotechnical engineer, I feel that you guys have, if there's any geotechnical engineers with us today, I feel like you have a very important role in this in the project. As a designer, I relied very heavily on the geotechnical engineers, and I'm going to say, if you could see me, I would do my air quotes, of the recommendations, because I say that because a lot of civil engineers, they will not take the responsibility of doing the pavement design. They actually say that they get it from the geotechnical engineers. I've spoken to many geotechnical engineers in the US that say that they don't do the designs, they just provide recommendations. So if you're a geotechnical engineer, I want to express the importance of understanding the correct way to design a parking lot or a concrete street, just for the fact that there is a lot of civil engineers out there that are relying on your recommendations. So a very, very important role. For the civil engineer, ultimately your stamp is going to be on the plans for the pavement details. So it's very important to have an idea and a good knowledge of how to properly design a concrete pavement. Now, here, this one was kind of new to me, and so I've talked it around with my teammates. And the structural engineer, if they are the ones that are doing the design for the pavement, you're probably going to see a large ticket item under the reinforcement. A lot of times they will design the exterior slabs like they would an interior with a lot of extra reinforcement that's not necessary. And we'll talk about reinforcement in just a little bit. From a contractor's perspective, the biggest thing that you need to be concerned with is that joint layout plan, as well as the other finishing aspects to a concrete pavement. But you should never go onto a site getting ready to place concrete without a joint plan already in your hands and fully examined and having any questions addressed beforehand. So again, those are different aspects of the project, and I encourage each of you to really kind of think about where your role is in that what I call the project food chain. All right, so the first thing that we're going to address is concrete streets. I'm going to just touch on the streets aspect here shortly, just a couple of slides, and then I really want to dive into the other ACI document for parking lots. There's a little bit of overlap as far as the inputs, and so we'll talk about those really briefly here, but we'll get into that here in a second in more detail. So ACI 325.12 R-02 is the current guide for design of jointed concrete pavements for streets and local roads. So if you're designing a concrete street or a concrete local road, then this is the document that you would need to go to. It gets a little confusing if you're not familiar with the ACI documents, because there's a lot of different numbers and whatnot, identifiers for these different documents. But basically, this is a committee that's put forth to provide the guidelines for paving local streets and roads. And the primary distress that this document, the 325, addresses, but it does make note of other distresses such as spalling or faults that do occur. But this is really primarily based on mid-slab cracking. So there's thickness design charts and within the 325 document, and they are based on axle load distributions. Both this document and the next document that we're going to be talking about do have appendices with the axle load distributions in there. So if you are someone that's very interested in what type of vehicles are being calculated in these designs, you can go back to the appendix on both of the documents and research that. One of the other big inputs that we have for pavement design is traffic. This is a table out of 325 for streets and local roads. You'll see the different street classifications there. Average daily truck traffic is one of the key ingredients that we need to design a concrete pavement. So this is, again, the chart for the streets and local roads. You'll need to know what type of street your pavement is going to service. And then we'll look at here in a minute how that differs for parking lots. So there's two basic charts that you will use in 325 depending on your support edge. So the first one here is 3.2A, and this is going to be for a pavement that has an integral or a tied curb and gutter or a shoulder. So basically that edge is going to be supported. And then there is another chart that you could use, the 3.2b, and this is without a curb or gutter. So if you have a tendency then for those vehicles to encroach on that edge, you're going to have higher stresses along the edge. And so if you compare those two charts, you will see that you will have thicker pavements with that unsupported edge, just kind of the difference between the two. So that's just a review of the Streets and Local Roads Guide. Again, there's a lot of overlap when it comes to the key elements for design in the two. And so I'm really going to dive in much deeper with the 330 design guide, and we'll look at this one. We'll kind of tear it apart and look at those elements that can also be used in that 325 guide. So ACI 330 R-08. So this is letting you know that this is the R is a report, and the 08 is the year that it was published. So this particular guide was published in 2008. The committee just met yesterday, and we are currently revising this document. And our fingers are crossed that we will have publication with a 2020 date. So we're working very hard on getting this out. But this is the document that you will use specifically for concrete parking lots. This is the only document available and out there for concrete parking lots. So if I could talk to you and have you guys talk back to me, my question that I always ask, and the answer is right here on the screen, is what does the H stand for in AASHTO? The H is for highway. A lot of times when we read specs or we read the geotechnical reports, we will see DOT or AASHTO 93 design guide used for concrete pavement design for parking lots. And that's really, I equate it to, I like this. And so that's like trying to take a brownie mix with this whole shut-in. My kids are loving to make desserts. They take a box of brownie mix and they follow the directions and they put it in the oven. And they hope that when the buzzer goes off, they open the drawer and it's a cake. It's a vanilla funfetti cake mix. They're going to be disappointed. They will get dessert. They're both desserts, but they are two different types of desserts. If you design a concrete parking lot with an AASHTO 93 guide, you're going to get a concrete parking lot, but you're going to get something that's pretty significantly over-designed. And so when we look at that initial cost comparison, it's going to be very, very difficult to be able to compete with anything as far as the initial costs. So so when you look at a highway design, highways are typically high rates of speed. They're going in one directional direction, traffic pattern. There's a lot of times, there's especially on highways, there's not a lot of curb and gutter, and so you're going to have that shoulder. So you're going to have a little bit more of that wandering tendency to the edges. So you're going to have higher stresses. You're also going to have a very high number, a high volume of the truck traffic, a lot more so than you would see for a typical parking lot. In a parking lot, when you look at a design, if you've talked to an architect, or if you're an architect, one of the things that they like to do when you've got a lot of pedestrian traffic is to slow down the traffic flow. So they do that with multiple different ways. So the speed aspect, again, it's completely in contrast to what we would see in a highway. We paint arrows for direction flow in a parking lot with the hopes that people will follow them. I'm 5'1" and drive a Suburban. I'm all over that parking lot. I use those arrows as recommendations. I don't. There's an inconsistent traffic flow in the parking lot, unlike what we would see in a highway type element. So, again, this is yes, it's a way to design a pavement, but it's not the right way to design a concrete parking lot. So some key terminology that we need to know. So we're basically starting to build our model, so how we can go in and do a concrete design. One of the first things that we need to know is the average daily truck traffic. This is not your Bubba pickup truck. This is not your standard cars that we see on the roads. These are more of your semis, your garbage trucks. These are more of your heavy load. Like I mentioned earlier, if you're interested in what goes into the traffic spectrums, you can reference the appendix in the back of the documents. So we're going to look at the average daily truck traffic. Now this is an average. When we do our design, you'll see that for the 330.8 or the 08 guide, it's 20 years, assuming that traffic every day for 20 years. The modulus of rupture, this is the flexural strength. So if you are somewhat familiar with concrete in general, a lot of times you'll hear 3,500, 4,000 PSI. Those are compressive strengths. The way that the charts are set up, it talks in flexural strength. So modulus of rupture is can also be described as flexural strength. So when we start looking at the chart, we're going to look at something that says 550 PSI. Please make yourself make a note that that is not compressive strength. That is flexural strength. Here in a minute. Table 3.3 in the 08 guide is the traffic categories. So we have our average daily truck traffic. That is the frequency of those large trucks. We need to decide what category we're going to use. So the different categories are there on your screen. If we're going to design for a library or a dentist office, we're going to look at category A. If we're going to design for the service lane on the outside that takes you around the different shops in that shopping center, then we're going to use for that. You can have multiple traffic categories within. And that is one thing that we like to stress is do not think that one size fits all. And if you're looking for an economic design, you will do your owner a favor by breaking up your site depending on its needs. Another element that we need to look at is the subgrade terminology. So two of the most common types that we find in the geotech report or references is a little k, the modulus of subgrade reaction, which is the equivalent, or when you want to think about what it is, you can compare it to the springs in a mattress or the spring, any kind of a spring. When you push down on the couch or the mattress, those springs are pushing up at some sort of a force. And so that pressure that you're feeling the springs provide is your K value. So it's basically the spring constant of your soils. The other one that we commonly see is CBR value, your California bearing ratio. Again, those are the two most common types. Now, if you're on the webinar today from Florida, you guys like LBR, the lime rock bearing ratio. You're probably, I think you're the only state that I've ever come in contact with that uses that. And there is a conversion out there to get you from an LBR over to the K or a CBR. If you don't have these elements in your geotech report, or you have not been given that information by the owner, you can go to the U.S. Department of Agriculture's soil conservation site, and you can get a description of the native soils in that area. Or you can look at, if you've got boring logs, you can look at the descriptions that are provided to you in that log. And then by doing that, then you can come into the table 3.1 and you can do an analysis and look and see, okay, what type of soils best describes what I've been given? If I know nothing about a site and I'm just doing some preliminary back of the napkin type design, I will typically assume a CBR of 3. And you'll see right here in this table right here, a CBR of 3 is kind of in the middle of the lowest support type soils. So we'll go on a CBR of 3, and then once more information is provided to us, then we can make those adjustments. So that's a pretty good assumption to begin with. So this is a standard table from the ACI 330R-08 guideline. This table is for unreinforced concrete, plain gray concrete, sitting on compacted subgrade. And so this is kind of what I would consider a base model for a car. We always start with this, but then we look at each project individually, and we deciphered, is there other elements that needed to be added to the section? Just like when you buy a car, you buy the base model, and then you can upgrade your car depending on what suits your needs. Same type of thing with a concrete parking lot design. You'll see that this is broken up into 6 different sections, and they're all based on that soils category. So earlier I told you that if I did not know the soils information, I would make an assumption of a K of 100 or a CBR of 3. So that will throw us down into this box right here. So this is the box that we're going to use here. The modulus of rupture, remember I said that was your flexural strength. So we're going to be in one of these four columns right here. Now there's two equations that will equate the modulus of rupture, the flexural strength, to compressive strength. It's either 8 or 10 times the square root of compressive strength is what your flexural strength is going to be. Roughly speaking, a 550 PSI is between 550 and a 600 PSI is going to be a 4,000 PSI compressive strength concrete. For this example, we're going to use which we're going to run through an example here real quick. We're going to use the 550 PSI flexural strength for our example. The next thing we need to evaluate is our traffic category over here. So if we are going to be designing, we're going to say, let's use our example as a dentist office. A dentist office may get garbage pickup once a week if it's a small practice and that they're separate. So we're going to say that this is a kind of an independent little office with very, very minor delivery, and their biggest truck will be our garbage truck. So we're going to say, we're going to do a category A for the site, and we're going to do an average daily truck traffic of 1. Now, when we put those inputs into this chart, you're going to see that our resulting thickness is 4.5 inches of 550 PSI flexural strength concrete, unreinforced, and at this point sitting on compacted subgrade. Now, if you're a designer on the phone, please don't pass out when you see 4.5 inches. I know when I do this presentation in person, I get a lot of head nods, no, shaking their head no back and forth, because a lot of designers have a 6-inch thick minimum. That's their rule of thumb. But I do want to stress to you that when you look at this design, there's a lot of factors of safety or rounding that is put into these designs. Just like we estimated a CBR of 3, more than likely we'll say that it comes back to the report that it's a CBR of 5. Okay, so we're being conservative there. If you order a 4,000 PSI compressive concrete mix, maturity, the 28 days, you're going to be well over PSI strength. We also, for the traffic, we said 1 truck per day. Again, that's for 20 years every day. And so you can see when all of these elements are put into this chart, we've got a lot of conservatism built in. So you can rest assured, if you've got a good 4.5-inch thick concrete section that's placed properly, it will provide you the necessary platform for the traffic conditions that you've specified here. And I'm going to challenge you, if you stick with me when we start looking at software, I challenge you to, there'll be a challenge at that point for you to kind of go in and if you say, no, I'll never design a 4.5-inch thick pavement, I want to challenge you to do something here in a minute. When we get there, I'll point it out to you. So thickness design is really just step 1. There's a lot of other elements. Like I said earlier, we built the base model of our car, but now we're going to really start diving in and looking at the different elements that can be added to our section. Some of the common questions that we have is about the subbase. I know in some parts of the country, they would not even consider putting concrete down without some sort of an aggregate layer. I know in some portions of the country, there is absolutely terrible soils, a lot of expansive soils. So there might be something that needs to happen to that subbase. Fibers are something else that we're seeing come through the industry that it's changed dramatically in my time that I've been within the industry. I know when I started about 11 years ago, almost 12 years ago in the industry, I didn't hear a whole lot about fibers, but I see very little being built today without fibers. So we'll look at that. Welded wire mesh, and then another very important topic is jointing. We'll hit a little bit of jointing information today, but I do want to I will remind you about a webinar that we have coming up specifically on jointing. But the first thing that we need to do is we need to establish that concrete pavements and asphalt pavements feel the stress load different. And that's noted by that red stress underneath the pavement. So when the wheel load comes over the concrete section, the concrete itself carries the majority of that wheel load. The stress then penetrates just slightly into that underlying layer. That's why it's so critical for concrete that we are put on a uniformly compacted subgrade. Whether it's 95, 98, 99%, it just needs to be a level or a uniformly compacted surface. For asphalt, each layer in itself is very weak, and so it needs all of those supporting layers to help hold that wheel load or that load that's coming across up. And so you can see that by the deep dip in that red stress model. Like I said earlier, fibers, we're seeing fibers used a lot. I know in the new document that I had mentioned, the 330-08 document, there will be a whole section for fibers. They're used for different reasons, most commonly to help with the plastic shrinkage cracking. If you have any questions diving into fibers anymore, just send us an email or you can type a question. We can definitely get you in contact with a ready mix producer or a fiber person in your area, a fiber distributor, and then you can find out a lot more in-depth fibers. This is an element that I see a lot of times come up in those cross sections when I'm reviewing plans. We see welded wire mesh in the majority of plans, and when you really talk to designers, they don't know why. They copied and pasted, and they really never gave a second thought to what was in their section. The problem that we get with welded wire mesh, or the steel reinforcement, is that a lot of times it gets embedded in the subgrade, or it's at the very bottom of the concrete. As you can see in the picture on the right-hand side, it has to be in the upper third of that section, or the upper half of that section, in order to really be able to do anything. But 330 says, hey, you really don't need this. You can cut your joints closer together, and that will help with that joints being close together. So if you're looking at your section and you're really trying to identify the elements that are not necessary, this is one where I would think that you could probably spend some time in researching and be able to eliminate it from your section. Dowels are another area that we're commonly asked about, dowels and tie bars. We don't really discuss tie bars in this presentation, so I just want to address it really quick without a slide. But tie bars tie. So when you think about like an entrance drive into, we'll say, into like a fast food restaurant, a lot of times they're about 24 feet wide. And if you have a longitudinal joint cutting that 24-foot driveway in half, so you've got two 12-foot panels. If there's no edge constraint, you're going to have a tendency for the momentum of those cars to push that outer panel away. You put tie bars in that longitudinal joint, and it will tie those two slabs together, and it will help with the horizontal drift. Now, tie bars do not provide vertical load transfer. So tie bars are horizontal. If you have a lot of trucks, you need dowels. So dowels will help you with the deflection that you would get from one slab to the next. And this is addressed in section 3.8.2. Now you'll see by this table, this is a table for the design for smooth round dowels. It does not provide you any recommendations for slab thicknesses less than 7 inches. So if you're designing a project and you've got 5 inches of concrete and you have dowels, I can pretty much guarantee you do not need round dowels in there. Again, the dowels will be one of the main requirements for dowels is going to be your truck traffic. So when you start looking at 150 semi-trucks per day, you're going to get a lot of movement between those two slabs, and that's going to require some dowels. So there are some instances where, and going back to that, if you put a round dowel in like a 6-inch thick pavement or even less than that, you don't have adequate concrete cover over that dowel. So once you start running a lot of heavy truck traffic, you're going to have a higher potential for cracking directly above that dowel. So there are some times, though, that you may have 100 to 150 trucks per day, but you're going to come in that 6.5-inch thick concrete section range. And it's during those times that we see plate dowels used. Now, they were typically used in more of the interior pavements, but we're seeing these used a lot on the exterior application. So you've got a thinner cross-section, a larger surface area, and that's going to help you with that load transfer from slab to slab. So again, round dowels may not be, it's not necessary in anything less than 7 inches. If you're in that gray area where you've got the truck traffic that would warrant dowels, this is the way you're going to want to go with the plate dowels. If you have any questions on doweling, the 08 document does not get real detailed with it. There's a new document that's coming out that I'll address here in a second that goes into much greater detail about dowels. And so you can get that document, a third document that we'll talk about, and look at that for more doweling research. Jointing, this is one of the last topics that we're going to talk about before we go into the software. But jointing is extremely important. If we design the concrete thickness correctly, we place it, correctly, we cure it, but we don't joint it at the right time, the location, and the depth, we could have a potential problem on our hands. I do want to make you guys aware that there is a 1-hour webinar on Thursday, April 23rd at 2 p.m. on jointing. It'll be specifically an hour on jointing. So I want to make you aware of that. So we're going to talk about the 3 main types of joints. The first one is a contraction joint or a control joint. I say that a control joint is nothing more than a pretty crack. If an owner walks out into their parking lot and they see random cracking, they're going to tell you that there's something wrong with their concrete. If the owner walks out and sees a cut joint, they're not going to think anything about it. And they're really serving the same purpose. They're relieving the stress of the concrete as it's going through that drying and the shrinking process. With the control joints, again, just like their name says, we have the opportunity to control where they go. And we also have the chance to control their thickness or their depth. The minimum depth that those joints need to be cut is 1/4 of the thickness. So if you've got a 4-inch thick pavement, then you're going to go 1 inch deep. We are seeing some industries standards going to 1/3 of the thickness, but 1/4 of the thickness is your minimum. Some rules of thumb is the horizontal spacing. So I kind of alluded to this earlier. If I get a call about a parking lot that's cracked, there's probably about 3 different scenarios that we look at to see if any of those are contributing factors to cracking. One of them is the depth that we just talked about, and there's a way to measure that. The other one is the horizontal spacing. The maximum joint spacing for your 4 and 4.5 inch thick pavements are 10 feet horizontally. And we'll look at, there's a table that's in 330 that I'll show you on the next slide. But basically, your horizontal spacing, we can measure that as well for another contributing factor to cracks. The third one we can't measure. You can measure it, but it's really on observation is the timing. And we'll talk about what happens if you don't get it in the right timing. But going back to the depth, we've already addressed that, 1/4 of the thickness, and then keeping your panels as square as possible. And then the big one, the rule breaker of this is sidewalks. We have, I've seen many sidewalks where they may be 4 feet wide, 5 feet wide, but then they're going to go 15 feet before they put a joint. If you get even a heavy loaded work truck in the middle of that panel, you're going to have a significant increase of probability for a crack in that mid panel. This is a table I alluded to just a minute ago. This is the maximum joint spacing depending on your thickness. We always recommend that you pull back from that maximum space. So if you are dealing with a 5-inch thick concrete pavement, the maximum joint spacing would be 12.5 feet. When laying out a joint plan, I always recommend pull that back. Pull that back to maybe 12 or 11 feet, depending on the way that your site plan is laid out. Yes, it may cost you more for a few extra cuts, but as any designer, as anybody that works in construction knows, if you put a manhole on paper, it's probably going to move slightly in the field. And so this way it gives a little bit of flexibility for the contractor when they're making the cut, so they have a little bit of flexibility without exceeding those maximums. The next kind of joint that I'm going to talk about is a construction joint or a cold joint. This is basically from placement to placement. You'll notice that it's squared off. It looks different than that control joint that we saw earlier. There's no load transfer in the cold joint itself, or we also call them the butt joint. If this is an area that's going to have more truck traffic, then we need to look at maybe putting in a dowel to help with that load transfer, because there's no aggregate interlock there. It's a squared off edge. If it's in an area that's going to be light traffic, then we need to look at maybe doing a thickened edge, and I'll show you the detail for that here in a minute. But that's a butt joint. In my travels across the U.S. and looking at a lot of projects, I see a lot of call outs for keyways. Keyways are no longer recommended in parking lots, and I believe that the only thing that I could find really was when it's looking at 8 inches or greater in it more of a mainline type paving application. So if you currently design using keyways, I urge you to go and research the section in the 330 document that talks about keyways, section 3.7.2. Go take a look at that, and if you have any questions after you read it, I'll be more than happy to talk it over with you. The last joint that we're going to talk about is an isolation joint. Sometimes they're called expansion joints. They're used interchangeably, but they really provide different, they really have different jobs. An isolation joint does just what its name says. It isolates the new fresh concrete from any fixed structure. So you can see in the image here, the detail that we are separating that new fresh concrete from the existing structure. If we don't, say that that structure is a column. If we do not have that isolation joint material in between those two structures, if one of them settles, if the column were to settle, and the concrete was basically stuck to that column, then there's going to be that concrete pavement is going to then settle with it, and so there's going to be significant cracking in that area. If you've separated those two structures with isolation joint material, then it allows them to move somewhat independently. So if you've got a column then that settles, it allows the concrete pavement to stay pretty much intact at its constructed elevation, and without having a significant amount of cracking. And you're gonna use this isolation material around any fixed structure. So if you've got light poles, you've got drainage structures, anything like that that's going to be in the pavement, then you need to make sure that it is fully wrapped with the isolation material. So looking at our some photos of what to do and what not to do, the upper left picture, this is an integral curb. It's placed integrally with the concrete parking lot itself. And when we draw this on the plans, we are going to make sure that we are showing our joints going all the way through the back of curb. We want to try to make that one continuous cut as much as possible. The middle right picture, if we would have continued extending these cuts out straight, then we would have had a small triangular area right there. And we would have had several acute angles, which would have resulted in usually fine, small cracking to happen there. Instead, we fillet or filleted, however you want to say it, in AutoCAD. We joined these two saw cuts about 1.5 feet, 2 feet away from the face of curb. We then went perpendicular into that curb and then followed through all the way to the back of curb. If you remember back to your geometry days, anything that goes in at a perpendicular goes in at 90-degree angles, so it avoids any type of acute angles. We want to make sure that we try to hit corners as much as possible with our joints. Now, if you've ever been responsible for a joint plan, you understand, and I totally empathize with you on trying to lay out joints. It can be a pretty tedious adventure, and I'll use adventure lightly, but it can take hours and hours, and really with the way that the site plans are made today, it's going to be nearly impossible to get a perfect joint layout. But it's really about evaluating what is going to be the best scenario for your pavement. If you've got to bend the rolls any, it's best to try to bend them in the light duty area or areas where it's going to see minimal traffic. You want to really focus especially hard on those areas with the heavy truck traffic to make sure we've got good jointing practices in those areas. Just a couple other pictures here. We've got a drainage structure here. We missed the corner. And you can see the concrete did exactly what we know it's going to do. It's going to go to the edge of that structure. If the owner sees this, you're probably going to get a call about it. Their concrete's broken, but we know that random crack is serving the same purpose as a saw cut. It's just in the wrong location. So trying to come off at a good angle and then come to the corner, we like to see something on the other corners as well. As far as joint cuts going up to those other corners. Now, I don't know the story behind this picture, but you can see once again, this concrete pavement cracked pretty much where we thought it would be as far as coming into this outer boundary at a perpendicular. Now, if there's no type of steel in here, then this piece right here, this corner piece, is going to have a tendency to fall off and it's going to be displaced. So if you've got certain scenarios where you know you cannot avoid these acute angles, you know there's going to be a high probability of cracking because of the joint layouts, then you want to go ahead and put some sort of a steel in there. So if this happens, it will stay together and it won't have an issue with coming off. All right, so this is the thickened edge detail that I was telling you about before. So if you have, in this case scenario, we have a free edge on the left-hand side here. We know, like I had mentioned earlier, we start doing the traffic wandering. As we get closer to that edge of that pavement, the stresses go up. Therefore, you would need a thicker pavement to be able to handle those stresses. By transitioning into a thicker pavement with the thickened edge, it then provides additional support for that wheel load. Here is an isolation joint. So this would be in a light duty application. Isolation joint. Instead of keeping it flat on the bottom, we've transitioned. And again, that is going to provide more integrity, structural integrity to the section by putting more concrete on that edge. There is no load transfer the way that this detail has been drawn across the isolation joint. So a couple of design tools that we have for you. The first one I'm going to talk about is the Concrete Pavement Analyst. This is a software that NRMCA has. If you are interested in the software, please send me an email and we'll see what we can do to get that out to you. This is a software that has to be downloaded. We're trying to eventually go to a web-based application, but this one right now is downloaded. This is not a design tool. This is more of a comparison tool, and I'm going to show you. I alluded to this earlier. The way that I like to use this tool specifically. But basically, you go in. This is the opening page. You put your basic project information in here. You would click on the pavement design tab, and then that's where you put in your project information. As far as the traffic count, you're going to put your concrete information in there, your soils and your traffic counts, and then the concrete strength, the three main elements that we see for concrete pavement design. And then the last one I'm going to show you here closer is this locally specific design. And this is where we get into that comparisons. The comparisons are made on structural numbers. So if it's been a while since you've never heard of structural numbers, let me give you a 2-second crash course. Basically, each layer of pavement, concrete and asphalt, and the material below it are assigned a coefficient for that type of material. So when you go in, for instance, concrete is the coefficient that is in the pavement designer, or the concrete pavement analyst is 0.5. So that is its coefficient. To find the structural number of a 4-inch thick concrete pavement, you would take 4 inches and you would multiply it times that 0.5. So your structural number of a 4-inch thick pavement would be 2. For an asphalt, you would take it for each of those individual layers, multiply each layer thickness by its coefficient, and then add them all together. So if you come to this locally specific design, this is where you have the opportunity to put in your asphalt design. So this is what you would typically spec on your plans. Now earlier, if you told me that you would not design a concrete parking lot in less than 6 inches, but this is pretty close to what your asphalt section is, 3 inches of fine graded asphalt over 6 inches of crushed stone. Based on structural number, you can see that provides a structural number of 1.86. The anecdotal concrete equivalent is going to be 3.72 inches. So this asphalt section structurally, based on those structural numbers, is equivalent to 3.72 inches of concrete. You'll see that there's a little red exclamation point there next to the 3.72. It's because if you were to hover over that in the program, it tells you that the industry does not recommend anything less than 4 inches. Now we are not suggesting that you would build your project with 4 inches of concrete, because when you would go to your design that we saw earlier, given the inputs, the traffic, soils, and concrete strength, we needed 4.5 inches. But what this tells me is this design for the asphalt is under-designed, so we cannot do an apples-to-apples comparison. So if I know I ran through this very, very quickly, we do webinars specifically on this tool. Again, this is not a design tool. This is a comparison tool. If you would like a copy of this, if you would like another personal webinar to go through the ins and outs of this, send me an email and we will get with you. We'll make sure that you've got it, copy of it, and we can go over how to use this. But again, this is a comparison tool, not a design tool. Our design tool is pavementdesigner.org. This is a free web-based program that's out there. NRMCA, the Portland Cement Association, and the American Concrete Pavement Association, ACPA, all put in some money, and we came up with this one-stop shop for many facets of concrete paving. I'm going to, real quick, before I jump into the program, I want to direct you to paveahead.com. This is our NRMCA's local pavings website. If you go down to the resources page or tab, under the additional resources, if you go at the bottom, you will see these headings. You can, this will be a link. This concrete industry pavement design tool is a link to Pavement Designer. So if you forget where to look, that will be a link. There is a free webinar with the slides as well as the recording. So if you want to find out about that software in more detail, you can upload that recording and the slides, and you can follow along. Just like with CPA, once you get in it, if you have any questions, please feel free to reach out to us, and we'll be more than happy to we can link in with you, and we can kind of discuss the different aspects of it. But it's a very good tool. So I'm going to jump out here real quick, and I'm going to go to Pavement Designer for just a few minutes and look at this. So again, it's pavementdesigner.org. It's a free website. If you have not ever registered, it's going to look a little bit different than mine. This middle area right here, register button. When you, if you have not registered, this icon right here will look different. It'll be sign in or register. Once you register, it changes to My Design. When you register, it gives you the ability then to store all of your concrete designs in one location. These are designs that you see. I don't have access to them. These are your personal there. when you open Pavement Designer, you have 3 modules. You have the parking module, the streets and local roads module, and an intermodal module. The parking lot, once you hover over them, it'll flip up and it tells you exactly what you are going to be designing for. It also tells you the methodology used. So for parking lots, it's going to use ACI 330, which is the document that we've been talking about, and it's also going to use StreetPave to make the calculations behind the scene. If you go to streets and local roads, there's a lot of stuff that's embedded in the streets module. So look at the flip up panel. You can see here it's designing jointed plain concrete pavements. This is also can be used for continuously reinforced as well as roller compacted. In this module, you can also do overlays. You can design overlays, and you can also design using composite systems. So again, there's a lot that's embedded. So it takes a little bit of time to kind of go through and see what all you can do. For the intermodal module, this is more for your heavy duty industrial. This is for not over the road trucks. So this is looking at your forklifts and your container trucks, things like that have been separated, or the container aspect of it. So that is a completely separate type of calculation. And we are going to be having a webinar coming up next week on the industrial guide that'll be resources here in a minute. But we'll go over the module for the intermodal in that webinar. So that's next Thursday. But getting back to this, when you come into the for a parking lot, you can see that the information that we talked about up to this point is in here. So if you do a calculation for a light duty parking lot, you pick your traffic, your design life, reliability, all of this information, trucks per day. These are all things that we had talked about before. If you have any questions, you can go to the help and you can toggle it on. And then whenever you hover over, it'll pop up and then it'll give you some information on help. There is a resource tab over here, and that has a lot of information on it that you can download about any of the topics that I talked about. It connects to different wiki pages. It's taking a little bit of time to go. Support, if you have any questions, again, about the software, there is a point person from each of the associations that you can then get in contact with for more information. So that's my portion of the presentation. And Phil's going to finish us out with the NRMCA resources.
I do have a little bit here on some resources. The best thing I can tell you is your best resource, I think, would be to go to paveahead.com, reach out to any of the paving experts that are listed there. But with regard to that, I will start with paveahead.com as the best place to begin. It is our newly branded website. There's all kinds of great information here. You'll see information on concrete overlays of existing asphalt, concrete parking lots, concrete pervious concrete, roller compacted concrete, additional a new section on concrete trails to go along with the new concrete trails design guide. It probably should be the first place you would stop. And while you're here, you can click on the Design Center. Amanda talked a little bit about our Design Center. It is formerly called the Design Assistance Program, but as our Concrete Pavement Design Center, we have engineers on staff who will look at your project, the information that you provide us, and we can make design recommendations for concrete pavement based on ACI 330 designs. If given the information, we can also provide some cost comparisons, life cycle cost analysis. All depends on all the information that you give us. Mostly what we will do there is a concrete recommendation, and we can take a look at specification review. Now, it will cover conventional concrete, both full depth and overlays. We can talk about pervious concrete. We can show recommendations for roller compacted concrete. We can include full depth reclamation beneath the concrete pavement. We can look at what I call composite pavements, perhaps a parking lot that might use conventional concrete and pervious concrete. The sky's the limit really at what we can do, but it's all based on what you provide us. The best information we give you comes from the best information you give us. If you provide us the site plan, the geotechnical report, the anticipated traffic count, those are the three main pieces we need that Amanda talked about in the tables that are in ACI 330. Additionally, if there's a local specification that needs to be met, if it's a particular project and you have specific asphalt and concrete sections already there, we'll take a look at those, compare them to what ACI says. And that also then provides you with a little bit better understanding of the design. At a minimum, if we have the site plan and the geotech report, we can still provide recommendations. We've actually done recommendations based on nothing more than a Google Earth photograph. In those cases, we provide a recommendation based on certain presumptions. In other words, we would say in our cover letter that this is based on the assumption that this project is in such and such an area where the soils are typically this, and this project is one where we would expect we might see this type of truck traffic and so on. And then we would basically say your mileage may vary. If you provide us more information, we can give you a more detailed report. What you will get in the report is thickness recommendations for standard and heavy duty pavements specific to your project based on the soil support and the intended traffic. There will also be recommendations on joint spacing. If there are areas that might need edge support, or if it's a thick enough pavement that should have some dowel reinforcement, those will be included as well. Also, if you include a CAD drawing of the project, we can provide a recommended joint pattern, the joint plan assistance. This is some contractors actually use this part only of the service in order to help with joint layout. And we'll provide recommendations on both contraction and isolation joints. Going back to Pave Ahead, also on that site, the resources that are available, and we have a list of resources for each one of the market areas. This is just an example of what's there. In concrete overlays, for example, there's a way to download the guide to concrete overlays of streets and roads and the guide to concrete overlays of asphalt parking lots, both of which are from the Concrete Pavement Technology Center. We don't have the actual ACI guides in concrete parking, but we do have a link there to be able to go to the ACI website and purchase those documents. Also, there's a lot of great support documents there. Just a sample of one here is a one-page flyer. If you're in the promotion business, so to speak, you're looking for something to use with your customers. Here's a one-page flyer that talks about the benefits of concrete pavement. You can print these out and use them as part of your message. And we have some concrete results success stories. Here's one in particular about a concrete overlay that was done for a school district in Illinois. And as a result of doing an overlay rather than a complete reconstruction, they saved $73,000. We have several results like this one that you can use to explain to your customer the benefits of concrete. Also on Pave Ahead, of course, our education tab. We have many webinars coming up. We'll be running webinars each week from now through May, and the list of webinars is there. The next webinar in our concrete pavement series is the Designing Industrial concrete pavements. That's ACR 330.2 R17, which Amanda did talk about earlier. This is, I like to say this is ACI 330 on steroids. This is a new document, and it is focused specifically on industrial pavements. Warehouses that are going to see 700 trucks a day, industrial, intermodals, those types of pavements that have a lot heavier use involved than a standard concrete pavement. That webinar will be next Thursday, April 9th at 2 o'clock, and you can go to the Pave Ahead site, click on the education tab up above there, and the whole list of webinars are there, and you can click to register for that. With that, I will say we do have some questions that have come in, and if it works for everyone, I'll read the question, and then Amanda, you can address. And they're in no certain order here, but the first question I have here is, Amanda, why doesn't the geotech engineer specify concrete strength, joint spacing, joint details, etc.? That might be the million-dollar question.
Well, actually, sometimes they do. Sometimes if you look at the geotech report, and they will give you all of the information in their recommendation, and a lot of times it's done, like I had mentioned earlier, with the wrong specific or with the wrong design manual. It's fine if they want to do it. It's great if that's what they've been contracted to do. But our goal as industry professionals is to make sure that the geotechs that are retained for that type of recommendation are out using the correct design guides. So whether it comes from the geotech engineer, again, they a lot of times will say that they don't do the design, that they're just providing the recommendations, and that it's the civil engineers or the designers' responsibility. Regardless of which one of the groups puts down those recommendations on paper, they need to be done with the correct design guides. And so it's extremely important that we communicate to both of those groups to do that.
Very good, thank you. The question that came in is, are you familiar with internal curing technology in concrete to extend the joint spacing in parking lots? Are you familiar with internal curing and how it reduces all manner of shrinkage and cracking?
There is a lot of talk on both the internal curing as well, and in regards to joint spacing, as well as fibers even, especially sitting on the committees. There's a lot of discussion on that. From a design standpoint, where we are at NRMCA is we will provide you recommendations based on the documents that we have, the most current documents that we have. So we would not take any of the really into consideration as far as the joint spacing recommendations about prolonging them. We would stick to what the design guide says, and then remembering that these are recommendations. You know, any of, the ones that we do are recommendations, but you can then take the information, the research that you find on those particular products, and then apply that to your base design. I do know, and like I said, in the rewrite of the 08 document when it comes out, there will be some information in there about fibers, and I believe that we are moving the market to potentially extending those joint spaces. I don't know personally. I haven't done an extensive amount of research in that, but we at this point we stick to those guidelines in the 330.
Thank you. This is another here on. I think it kind of goes to the geotech again. Am I right in assuming that for thickness recommendations, civil and structural engineers would require a K value, sub-base bearing capacity? If so, what are the most readily available test methods?
I do, yes. Generally, the civil does request information. There will be a lot of additional information in a webinar I want to inform you about on the 16th of April, so in 2 weeks. at 2 o'clock, Eastern time. And it's going to be specifically for the soils and looking at the different tests available for the subgrade. So I'm going to give you that as a teaser to come and join that webinar series on the 16th.
Very good. That was a great advertisement, a nice segue for us there. Here's a good question. I've heard this from others in the past as well. Can concrete pavement be designed without reinforcing by increasing the strength of the concrete or the thickness of the concrete? And is this what ACI 330's table 3.4 is showing us?
Okay, let me go back to table 3.4. Okay, so table 3.4, again, when you look at the criteria for that table, that is for unreinforced concrete. When you start doing the heavier loads, when you start getting more into the industrial side, and you then are given the option whenever dowels become an opportunity for you to be able to incorporate into your design, you then can potentially reduce the thickness of your pavement by putting in reinforcement. There is an appropriate time and location for that reinforcement. If it's strictly an economic thing, then you really want to weigh out, like, is it really economical to put in all of the doweling and the reinforcement just to save a half an inch of concrete? As far as the concrete strength, yes, you can see that when you look at that chart. If you play with the concrete strength, there is a potential of reducing or thickening up your concrete section. But we do want to warn you not to arbitrarily just make, if 4,000 is good, that means 5,000 should be better. There is a point where you're going to potentially cause harm to your pavement, and it's going to end up costing you more. So you don't want to go thicker for the sole purpose of thinning, or sorry, stronger for the sole purpose of thinning up your pavement. We typically will see a durability would be one of the big factors of going to a higher strength concrete, not necessarily a concrete or a thickness reasoning.
Thank you. Next question. What is the proper installation method for welded wire mesh in concrete pavement to avoid it from sinking to the bottom of the concrete?
Don't include it in your specification, and then that solves all problems right there. Really, ACI 330 doesn't talk about, it doesn't really get into great detail about it, about the construction side of it, just for the fact that it's not typically used. We don't normally see it. You know, the typical things that we see are, you know, using your chairs, the hooks to pull it up. It's a battle. I think that's the $1 million question when it comes to welded wire, the mesh or the reinforcements, is how to get it up and keep it up in that upper portion of the concrete. Maybe that's something that someone can improve the chair system on to make it a no-full system. But to me, the number one way is don't specify it.
I would agree. I've got 3 questions on jointing, and I'm going to put all 3 of them together. The first question is, if I can find it here, I was under the impression that we didn't want to extend the saw cuts deeper than 1/4 of the thickness to maintain aggregate interlock. The next question tied in there is, why not have joints at 1/3 the thickness? And then the third jointing question I'll put together is, do you recommend cutting the welded wire mesh at every concrete joint? I've heard that helps with horizontal movement intended at each joint.
As far as the, I'm looking for those now because that was a lot.
Let's take each one individually then. First,
we'll
talk about.
Yeah, if you can redo the first one.
The first one, I was under the impression that we did not want to extend saw cuts deeper than 1/4 thickness to maintain aggregate interlock. I guess that's
okay,
kind of
right.
True or false.
Yeah, so it really depends on the type of aggregates that are going to be used in the actual mix. That's going to be really the determinant. When you go a quarter of the thickness, you're sufficient to provide that reduced cross-sectional area to encourage those built-up stresses to congregate in that area and continue the aggregate interlock. A third of the thickness. It's really there's some the industrial document really goes into it quite a bit more as far as the recommendations of doing a third, but a lot of it is really going to be dependent on the aggregate types.
All right, that kind of answered questions 1 and 2. The third part of that question was, do you recommend cutting the welded wire mesh at every concrete joint? I've heard that helps with horizontal movement intended at each joint.
You know, I've heard mixed opinions about this one. I just went back and looked up at HCI 330. I did not see anything in 330 when I looked at the welded wire, the reinforcement steel, distributed steel section. I did not see where they made any mention of it. That's something that I would dig in deeper because I want to make sure that I have the facts for you. So I would look at it. I will be able to look it up, and I can get back with the original poster to send them to the appropriate section of the document. So I'm going to table that one.
We could also go back to your recommendation on not even using welded wire mesh, and then you wouldn't have to worry about that.
There you go. Maybe that's why 330 doesn't address it.
Our next question: if we talk about steel fiber, they're susceptible to rusting when exposed to moisture. Is it really sustainable to use steel fiber in concrete?
This is what I'm going to have to defer. Yes, it is going. Steel fibers are going to be susceptible for that. I will again. It's one that I'm going to defer until a later time because I would like to talk with my steel or my fiber folks. Phil, do you have anything to add on fibers on this question?
You know, I really don't. I know steel fibers are, I think most of the time I see steel fibers used in an interior application, industrial floors. Not being a chemist, I would maybe throw this out that let me go back to my experience being in the insurance industry. If a boat sank, we left it sank as long as we could in the water because it didn't start to fall apart, didn't start to oxidize until we pulled it out. If you have steel fiber in the concrete and it's held in the concrete without getting air to it as well, it may be less likely to corrode. Again, I will probably default to the fiber folks on that for better clarification, but you know, that would be I think the first part of the answer would be I've not really seen steel used in exterior, more in an interior slab. I like this question. Not that I don't like the others, but I think this is a very pertinent question. Pavements designed as recently as 10 years ago are being exposed now to numerous UPS, FedEx, and Amazon delivery trucks. How do you account for the increase in truck traffic?
And that's something that needs to be discussed. If we have that information ahead of time, we can make those assumptions. When you are doing a design in Pavement Designer, you can allot for a growth percentage. So if this is going to be phase 1 and you're in an industrial area, you can assign a growth percentage rate to your design so that it will take into account bringing on board other vehicles accessing your roadway. Phil, I have a question since I just talked about Pavement Designer that someone had. The question was, the Pavement Designer software does not include output results for dowel bars. Is there any reason? Parking lot module does not take into consideration dowels, and the reasoning being in most standard parking lot applications, you're not going to have the frequency of truck traffic to really warrant dowels. Again, if you start looking at dowels, you're going to look at, first of all, the thickness. The thickness for dowels needs to be for round dowels needs to be 7 inches or greater. So when you look at that design chart, you're going to have a lot of trucks to get there. Most standard parking lots do not have that truck frequency. If you go to the streets and local roads, the streets module, and you run through the streets module, you will be given the output for dowels. And so you can see the comparisons there. One thing that I would caution you about is that you will see a dowel recommendation printed on your screen, and it may come out like 5.5 inches. There's a slight shading over that, and so if you were to hover over your mouse over that 5.5 inches of dowel design, it'll tell you that dowels are not typically recommended in something that's that thin. So if you're looking for the doweling aspect of it, go to the street module. You can run parking lot traffic spectrums in the street module. So if you're looking at doing a more industrial site and you want to look at dowels, you're going to have over-the-road trucks, then use the street module, putting in your parking lot traffic designations, and then you can run it with dowels. So that was a long answer to that.
Thank you. Next question, would you use welded wire mesh or rebars for odd-shaped sections?
A lot of times we'll just see the distributed steel put in there. I believe is how the majority of the industry does it. But like one of our fellow attendees says, welded wire, don't use it. So there's different ways to do it. Again, I think it depends on the size, the location, what exactly is happening there.
I think it's quite common also to sometimes see in those odd-shaped sections, you might see welded wire or particularly fiber used in there.
I was getting ready to say it seems like we're transitioning to a lot more fiber in those areas because they basically will kind of help crossover, kind of hold it back together. Stitch it, I guess the word is stitch that I like to use. It stitches it together.
Mm-hmm. This next question may be another one that's answered in the soils webinar when it comes up. But the question is, when it comes to drainage and expansive clay soils, is the NRMCA providing any guidance on how the designer can address these items?
Well, being that the webinar is put on by Brian Killingsworth, who lives in Texas, and I hear so much about the highly expansive soils there, I can pretty much guarantee you that in that website or in that webinar, you will be talking about highly expansive soils and how to deal with them. So I would really defer that because it's something that we don't really have time to get into here, but there is some information out there in the ACI 330 document, but you'll find a lot more information as well in the webinar.
Thank you. Next question, what marketplaces in the country have you ever seen just 4.5 to 5 inches of concrete designed and placed? I think that's a good question because ACI 330 recommends these pavements at 4.5 or 5 inches, and yet the design community has a tendency to think, well, 5 is good, 6 is better, so let's design it at 6. Do we have experience out there where we've seen ACI 330 recommendations followed and they're using 4.5 or 5 inches of pavement?
Yes, and I also want to point out, so we have a, Phil, I drew a blank, help me with our case studies. We're working to compile projects across the United States that do
concrete tracker.
Yeah, so Concrete Tracker, we're looking for projects across the U.S. So for those of you in areas that have concrete pavements down there, if you've designed concrete pavements, we're looking for those projects that we can then populate a map, an interactive map on the web, where you can go in and you can pull down and say, okay, I want all 4-inch thick concrete pavements, and you can see the different projects that we've populated the map with those type projects. I can tell you that we do have 4.5 inch, 5-inch thick concrete sections out there. We see them a lot in banks. We see them in the doctor's offices, things like that, where it's guaranteed that we're going to have, typically it's a tighter site. It's not necessarily that that front road in Walmart, where it's going to have a lot more of the truck traffic or even the RV traffic, but really kind of thinking and trying to incorporate what all traffic is going to have access to this site. In saying that, when you design your pavement, the traffic is considered. There are allotments for a truck to come into your pavement. So we may say it's a dentist office, and so it's not going to see it, but you have to design for at least one truck per day. And so that will basically absorb those trucks that go where they're not supposed to go. It does still account for those and provide adequate structure there. But basically, you're looking at your extremely light duty, your public works buildings where it's pretty much just your pickup trucks, the parking lots for warehouses where it's the employee parking, and then they've got the trucks are all going to another area. Those are prime locations. And like I said, we find those throughout the U.S. And our hope is for anybody that's listening that has designed those 4-inch thick pavements to let us know about them, and we'd love to showcase those on our concrete tracker.
What are the effects of equal Portland cement concrete pavement and hot mix asphalt pavement designs relative to site excavation, granular import, etc.?
So when you compare the thickness of a concrete section, so when you compare them structurally, a concrete section to an asphalt section, your asphalt thickness is going to be thicker than the concrete section. Again, remembering that concrete, when it comes to ACI 330 design, it is a design that is basically concrete over compact. And so for a scenario like we talked about earlier, the example, it was 4.5 inches of concrete. So if you're in a position of cutting, you would then, if say that you were at elevation for the pavement, you would cut the 4.5 inches. For the asphalt, you've got every single 3 inches of asphalt, 6 inches of the aggregate base. Then you're looking at a much thicker pavement. So in excavation, if you're in a cut situation, concrete is definitely going to be the more economical way to go.
Oh, there we go. I muted myself. Also, actually, from the same person, I'm trying to get back to the question. What are your opinions on the value of the maturity curve monitoring? Return to service as a consideration for a lot of clients when assessing asphalt versus concrete.
All right, I'm looking for the question so I can read it again.
I can read it again to you. What are your opinions on the value of maturity curve monitoring? Return to service is a consideration for many clients when assessing asphalt and concrete.
It is, and we, I'm sorry, go ahead.
No, I was just going to say, I think we're talking maturity testing versus 28-day compressive strength. And, people think you can't drive on the concrete for 28 days because we got to get up to strength. So.
Exactly, and that's what I was going to address. Is a lot of times that there is the misconception that concrete, cannot be open for 28 days. For those of you in the municipality world, when we talk about concrete paving, a lot of times it's that not being able to open it up as fast as you can with other paving materials, and we absolutely can open it up quick. There's admixtures out there, whatnot, that can get us open a lot quicker. So. I definitely think it's important to do the proper testing to get it open as quick as possible, and you don't have to wait for the 28-day strength to be gained.
I think we've got time for one more question here. There are a couple of other questions that haven't been answered. I apologize we didn't have time for all of them. Any question that we have not answered here, we will respond directly to the person who's asked through an email. But the last question we've got here is, I'm often required to design even a lighter duty pavement area to accommodate fire trucks. I think what they're saying is even when they're looking at a lighter area, they're required to design it to accommodate fire trucks. You are talking 1 truck a day. Would that include a design for emergency vehicles?
So we look at emergency vehicles a little bit differently. If you've ever, and I never have really paid attention to emergency vehicles until I started this design, but if you've ever looked at fire trucks, for instance, there's a whole assortment of different configurations of the different types of fire trucks. What I would say is that, well, first of all, in the revision of the 330 document, there is going to be a traffic category specifically for fire trucks. So if you are designing a fire truck, you can go in, select that designation, and you can see what that thickness would be required to be. Until that point, I would highly recommend that when you are doing a pavement design, find out, you can call the local fire department if you aren't sure, what type of trucks they typically run, or you can just do an assumption of one. And then at that point, you can get the axle configurations and the weight of those trucks so that you can do a very precise design to make sure that you're not designing for a truck that's maybe, you know, a small truck, not a whole lot of ladder extensions on it, because those things can get pretty heavy and can do a lot of damage to the pavement. So you may want to do, basically in Pavement Designer, you would go in and you would create a different axle load configuration for that specific vehicle. It sounds a little complicated. Again, that's one of those things that if the webinar for that does not address it, feel free to give us a call, and we can walk through on how to put in a custom vehicle. But that's typically how we would look at it if we're going to design it specifically for that in mind, until we have the new document that will allow us to do it on paper, design on paper.
Well, very good. Thank you very much, Amanda. I want to thank you for a great presentation, very informative. I'd like to thank everyone for joining us today. I hope that you got a lot out of the program. A reminder that we do have another webinar next Thursday, and it would be Designing Industrial Pavements, ACI 330.2 R17. Hopefully as informative as the one you saw today. You can go to paveahead.com, click the education tab, and you should be able to register there. With that, I'll say once again, thank you much. Have a great day, and we hope everyone stays safe out there. Take care.
Thank you, guys.